Good afternoon.
Good afternoon, ma'am. Good afternoon. Am I audible to you? Can you please confirm?
You are audible.
Hello, ma'am. How are you?
I'm doing well.
Your audio is good. Everything
Okay,
works fine.
perfect. Thank you for confirming. Let me know when I should get started.
Yeah, just allow me a minute.
Sure,
There are people already in the waiting room as well as we're doing the YouTube live stream also for
okay,
those who can access it later. So in meanwhile, within a couple of minutes, we'll be beginning.
sure.
Okay. Good afternoon, good evening, Kapil ji. Am I audible to you? Can you please confirm?
Hey, hi Manoj. I'm Monalisa. Good evening.
Good evening. Thank you for coordinating this.
Hey, no
So,
problem.
Monalisa ma'am, just before we begin, also, I would like to know, is there any kind of presentation you are going to present? So you are muted. We're unable to hear you.
So sorry.
Mm.
Yes, I would be sharing my screen for a presentation as well as software demos on MATLAB.
Uh, Can you just like quickly do a demo? Then we'll be allowing all the participants and go with the
Okay,
script.
okay, sure. Let me know if the screen is visible. Is it
Yes, it's
working?
visible.
Okay, it's working, right? And if I bring my MATLAB screen also, you are able to see it, right?
Yes, the MATLAB screen is
Window.
visible also. Yeah, yeah. So I'm just starting the allowing the participants for now, and
Sure.
we'll wait for a few more minutes, then we'll begin. So So I think we'll begin now. Meanwhile, the participant will join in between, as well as we're on live in YouTube also. And here again, we have joined by Mr. Manas Kumar Samantra, is the CIO of AIC Nalanda. Also, would request you, Manas, to turn on your camera. Am I audible? If anyone can please confirm. Am I audible? And can anyone please confirm?
Yes, Manoj, you are audible.
Okay, I think let's begin now. Meanwhile, people will join in, students and the students. Okay, so very good evening, everyone, and myself, Manoj Kumar, program manager incubation at AIC Nalanda. And on the occasion of National Technology Day, that is today on 11th May 2026, AIC Nalanda Institute of Technology Foundation, and here we have FabLab as well as MathWorks collaboratively organized this particular virtual webinar, that is technology in action from idea to real world implementation, to celebrate this National Technology Day. Again, National Technology Day is observed to recognize the importance of technology innovation and scientific advancement in shaping the future. To today's session, we aim to help participating students, move from school students and as well as college students, to understand how ideas are transformed into practical solutions through these technical implementations and real world applications. We're delighted to have students from Nalanda Institute of Technology as well as various schools joining us over YouTube platform. So we hope today's interaction will add value to their learning process. And now, I would like to welcome Dr. Monalisa Pal from MathWorks, Mr. Kapil Pal from MathWorks, and Mr. Manas Kumar Samantrai from AIC Nalanda, who joined with us for this seminar, as well as all the participants who is joining in various platforms. So before we move forward, now I would like to request Mr. Manas Kumar Samantrai, Chief Innovation Officer of AIC Nalanda, to deliver the special address and share his thoughts on this National Technology Day. Over to you, Manasa.
Thank you, Manoj. Good evening, everyone. Uh, Esteemed CEO, sir, distinguished guests, students, and dear participants. Uh, it's a matter of immense pride and privilege to address this gathering on occasion of National Technology Day. Today, as we celebrate the spirit of scientific achievement and technological advancement, we also recognize the importance of innovation, entrepreneurship, and the collaborative efforts in shaping the future of our nation. This celebration, this National Technology Day celebration, becomes even more meaningful with the active contribution and support of the of our organization, that is AIC Nalanda Institute of Technology Foundation, which has been continuously fostering the culture of creativity, research, startup development, and problem solving among students and young innovators. The innovation department of AIC Nalanda has played a significant role in encouraging innovative thinking, nurturing future ready entrepreneurs who are capable of addressing real world challenges through technology driven solutions. So, today, uh, technologies such as artificial intelligence, robotics, Internet of Things, drone technology, renewable energies, sustainable energy, automations, machine learning, cyber security are redefining every sector of society. In this rapidly evolving world, innovation and entrepreneurship has become equally important alongside the technical knowledge. Institutions and innovations ecosystem like AIC Nalanda are creating platforms where ideas are transformed into impactful solutions and startups. I would especially like to appreciate the effort of each and every member of AIC Nalanda for organizing activities, mentoring young innovators, supporting startup incubation, and creating opportunity for students to explore their potential beyond conventional learning. Okay, we know that we always follow the regular academic syllabus, but being an engineer, that is not going to give us result in any way. Just go through the syllabus and pass in the examination has got no meaning. So we need to think out of box. So, as AIC Nalanda has already taken initiatives and which are most essential for building an innovation-driven ecosystem aligned with the vision of Atmanirbhar Bharat and Viksit Bharat. To the students and young innovators present here today, I would like to say innovation begins with a curiosity. Never hesitate to think differently, experiment fearlessly, and work towards solutions that can create a positive social impact. Every challenge around us carries an opportunity for innovation, and as you all know that uh, we have a fab lab here which is equipped with many of the machineries and equipment. Okay, always try to come to the fab lab, use the fab lab and turn your innovation into reality. So, may this National Technology Day ignite new ideas, inspire innovations, and motivate all of us to contribute towards a technologically empowered and innovation driven India. Thank you. Thank you so much.
Thank you so much, Manasa, for your words and inspiring, like ending your special address with this inspirational tone. I hope the students who is participating now from Nalanda and from schools who is watching, so that might inspire you to start their innovations journey maybe today or whatever they are thinking about. That might ignite them to start something. Okay, so moving forward with our agenda now. Also, now I would like to request Mr. Kapil Jim from MathWorks to say a few words, say a few thoughts on this National Technology Day with our participants. Over to you, Kapil Jim.
Uh, Thank you, Manoj. I think it's a privilege for MathWorks to be here on this platform, and we're very happy to have AIC Nalanda as a partner in the MathWorks Accelerator program. I remember it was, I think, 3 to 4 years back when we had signed officially AIC Nalanda as a partner in the program, and we see, quite a few programs being hosted by your incubation center where themes around innovation and entrepreneurship is something that you keenly focus on. And today, I think this session by Dr. Monalisa, I'm sure this will again help students get some insights around what is actually happening in the industry and more so, leveraging technology in building some of these solutions. So yeah, so happy to be here, and I think as earlier in the keynote, Sir was mentioning, I think curiosity is certainly something which we all should have, and then that really leads us to building out solutions that really are impactful and sustainable in nature. So, wishing everyone a very happy Technology Day. And I think from here, maybe Dr. Monalisa can take it forward.
Just allow me a minute to formally introduce Dr. Monalisa. It's now my pleasure to introduce our speaker for today's session, Dr. Monalisa Pearl, Senior Engineer Education Team at MathWorks. Dr. Monalisa has been actively working with faculty members and researchers across disciplines in the areas of STEM education, curriculum development, and research initiatives. He holds a PhD in computer science from the Indian Statistical Institute, Calcutta, and her research interests include machine learning applications in healthcare as well as optimization strategies for energy management. Now we'll be deep diving into how exactly technologies are getting leveraged. So, Monalisa, ma'am, over to you.
Thank you so much, Manoj, for the warm welcome. Thank you, Professor Hamantara, for the keynote and igniting the curiosity among the participants. I just want to clarify whether the participants have access to the chat.
Yes, they do have access to
All
the
right,
chat.
that's amazing. Okay, so I'll be sharing my screen and let me know once you're able to view it. Are
Yes,
you
ma'am,
able
it's
to
visible.
view my presentation?
Yes, the presentation is visible and it is in full screen.
Perfect. Thank you so much. Yeah, so good evening, everyone, and welcome to this particular talk. We are going to talk about from classroom to boardroom. This particular tool by MathWorks, MATLAB, is immensely used. It's the same platform that you will find in industry as well as in multiple academic institutes across India, across the world, wherever you go for your higher studies or even into industries. Uh, in many of the places, you will find this platform. And we are going to break down today's talk into this four particular sections. We're going to briefly start about the industry relevance of simulation platforms. We're going to talk about AI in real world applications. Then we are going to talk about the modern approach of problem solving using low code and AI assisted workflows. And finally, we are going to talk about some resources that you can take away from today's particular discussion. So, without further ado, let's deep dive into this particular context setting of today's talk. So, we are from MathWorks, and our motto is accelerating the pace of engineering and science so that the problem idea to innovation, idea to implementation is what you can particularly focus on without worrying about the intricacies of how to implement your program, how to write your program, so you can develop your solution more rapidly. Across different applications and industries, you will find our tools, MATLAB and Simulink being used. On the left hand side, you will find subjects that you would also study in your colleges, you will also study in your schools. And on the right hand side, you will see different industrial sectors where each of these subjects will come into play. And each of these different sectors takes into account different conceptual skills that you developed throughout this curriculum that you see today. National education policy today focuses on interdisciplinary curriculum. So, if our systems, if our industrial sectors are, uh, you know, taking applications from these different subjects, the curriculum should also be interdisciplinary. What I'm trying to say or convey here is these industrial sectors rely on something known as engineered systems. What does that mean? It's a combination of elements which rely on things like maths, physics, chemistry, and all of those laws of physics, all of those laws that you study in your school, colleges that comes into play. And that helps in developing systems, or rather systems of systems, and you'll see it everywhere where the fundamental common functions are same. It's modeling, it's algorithm design, it's simulation, it's analysis of data, analysis of different signals, images, And finally, we are now in the era of prototyping. So we want to focus on deployment. We want to focus on even enterprise scale solutions. So deployment would be a prime focus in all of these aspects. But what do we see in real world physics, real world application areas? We would value these engineered systems that address real world solutions or real world challenges. And I have picked up four key areas that are now you will see trending across every particular domain. We see wireless communication, it's the era of 6G. We have autonomous systems, drone delivering packages to multiple stations from source to destination. We are talking about grid based solution where renewable grids are coming into focus, and we are also migrating slowly from fuel based engines, from combustion engines into electric vehicles. The transition may be in terms of hybrid or fully electric vehicles. But across all of these platforms, you'll see some commonalities in terms of the foundational skills. But let's take a very simple example. And all of this example you'll find in MATLAB documentation, which is a very rich collection of real world examples. So I've taken this example that says and semantic segmentation visualization using something called as Unreal Engine. And the simulation is very much necessary in today's world because we have the computing power in today's world, we have digitalization in today's world, and we also have access to different servers, different high computing facilities, and we are able to simulate various synthetic scenarios that reduces our cost of real life testing. Real life testing is extremely expensive, and this is a low cost solution that simulation can provide. That's why industry today heavily relies on simulation. But uh, from this MATLAB documentation, let me pick out this example. Let's open MATLAB. This is the example, and in every MATLAB documentation you can click on this copy command and paste this command in MATLAB's command window. So first, let's look into what does this particular block or particular model does. Let me simulate whatever is there in the example first. So what it does is it brings up a drone. Let me bring the window from the other screen. So what it does is it brings up a drone. The drone, as you can see, is moving in the forward direction. It's not rotating in any direction. Along with the drone, it also brings up three different windows. Let me bring them one by one on the screen. One is called a semantic segmentation display. So it kind of segregates the scenario into different labeled components. You see red buildings, you see purple roads, you see green footpath, you see white poles. Then on the right hand side where you see the grayscale image, it's a depth display. So very far away distances are all white and very nearby distance are all black, and in between everything it's shades of gray. And on the top right hand corner you see the RGB camera display, of course. So this is the simulation display. This is the semantic segmentation display. This is the depth display, and this is the camera display. And the simulation continues for roughly about 10 seconds, very slowly, and it ends. But I want to take this example and modify it a little bit. So what I'm going to do is open up MATLAB on my mobile. So if you are aware, MATLAB can be downloaded on your mobile, on your Android, on your iOS platforms also. So I have recorded this example just a while back. So what I'm doing here is opening up MATLAB mobile on my mobile phone, on my Android device. And if I run this particular section which says mobile dev list, it will try to see if I am logged into my MATLAB from another device. And you can see I'm logged into a Vivo phone from another phone. and this is my desktop. So from the Vivo phone, I'm trying to access orientation sensor. I enable it and start logging data. And the baseline I set it to azimuth 0. Then I open the same, model again, and every rotation is set to 0 initially, but I am trying to modify it using the orientation sensor data. Your pitch roll I'm trying to modify. I'm changing the sampling time so the simulation is little bit faster, and now it is going to execute for 65 seconds. The depth display, it's saturated at 150 meters. Everything beyond 150 meters is white. I have the RGB display and I have the semantically segmented display. So the UAV labels I have turned into RGB values and I have shown that separately. So remember the three displays we had along with the simulation display. So what is going to happen from now is I'm going to bring the four windows that we saw. Now you can see the simulation is little bit faster because I have varied the sampling time. And as you can see, I am moving my mobile. My drone kind of moves. So as you see from the bottom, the semantically segmented images also move. Now what I'm going to do with this real world challenge is I can use the semantically segmented data as a ground truth and the RGB image as my data and train an AI model to achieve whether I can actually identify which are the pixels belonging to buildings, which are the pixels belonging to grass, which are the pixels belonging to footpath, which are the pixels belonging to poles, so on and so forth. But that brings AI into the scenario, right? That's why today's world we are going to say everything is AI driven systems. I may be estimating a little bit over why I say everything, but you'll see AI in practice in almost all phases of life. So AI started off in 1950s. AI was there, but it did not create so much hype back then. Why? Because the computation power back then was relatively limited. We did not have so much of big data storing capability or capturing capability back then. When that kind of came into picture in the 1980s, the statistical methods were again applied on different tasks and it started the era of machine learning. In 2010, it started off a typical type of neural network and it started building on that. So in 2010, the computation power immensely increased and you started off the era of deep learning. And today we are standing in the era of a particular type of a deep neural network model, which are known as large language models, LLMs, and that brings into our today's era of generative AI. But what does AI tell you? I said systems are AI driven. Simulation solutions would be AI based solutions. Our real world solutions would be AI based solution. But why? Because there are two ways of problem solving. Earlier, we used to solve problems like this. We have data, we would fit them into functions and give some output. Whatever the program is supposed to do based on our input values, it will give us some output. But today there is a role reversal. From the output, everything comes in the form of data, and everything together, all the data is fed into computer. The computer is supposed to spit out the program. And in terms of the AI world, we tell that program is our AI model. So essentially, it's supposed to learn the relationship between input and output. But the systems or the AI driven systems, if you look very closely, it's kind of divided into four segments. It's not just about AI modeling. If I demystify it, it starts with data preparation. The data that I got by moving maybe the drone, the data that I capture through my mobile camera's video, I need to clean that. Some of the sensor data might be missing. Maybe I am recording, there is a background noise, I need to clear that out. Maybe there is a stabilization issue, so I need to make the video first stable in terms of optical image stabilization. Maybe I need to do some sort of filtering. So all of those comes into picture. But which particular type of smoothing operation, filtering operation, data cleaning operation is particularly suited for a particular application, that comes from the subject matter expert. So that's why a human must always be in the loop. However, in certain scenarios, maybe it's too complex to gather data. In those scenarios, also, simulation is very much essential because we can then generate also data. Nowadays, in the world of Gen AI, you all must be generating images from your different platforms, which can be, ChatGPT, Gemini, Meta AI, and so on and so forth. So once you have the data, be it synthetically generated or captured from sensor, from databases, you come into the second stage of AI modeling. In the AI modeling, you can have it only on one platform, which can be MATLAB, which can be any other platform. You can also interoperate between different platforms. Maybe your particular model is now only available in Python, and your data cleaning operations is available in MATLAB. So you can interoperate between different platforms. We also have hardware accelerated trainings these days. Sometimes we deploy our solutions, everything on a hardware, and we capture the data also through our hardware. Sometimes we have GPUs into the scenarios, so that kind of makes the training process much faster. All of those caveats are a part of the AI modeling vertical. Then comes the third phase where we talk about simulation and testing. AI module is just a part of the scenario. I started my talk with engineered systems, which are systems of systems. So you are going to integrate then your AI model into a complex system, do a system level simulation, and verify or validate whether that has passed various edge cases. Once you are satisfied with the modeling, you then put the model into somewhere that is going to be a standalone application. That standalone application can be an app, that standalone can be a handheld device, that standalone application can go and sit on a very remotely placed microcontroller. So it can be various things. So it can be an embedded device, it can be edge, cloud, desktop, so on and so forth. And interestingly, the MATLAB toolsuite supports this end-to-end development. I'm going to pick out a few examples from industry which has seen strength in each of these verticals. For example, you may be familiar with this particular organization, Bharat Electronics, BAIL. You may be familiar with this particular application, and they lead in radar surveillance. In radar surveillance, for estimating the elevation angle of the target, it is sending a radar beam, but that is getting environmental perturbations. So how does it accurately estimate that particular angle? It cannot do a simple trigonometric solution. It cannot, you know, draw a triangle and find out what's the tan theta. There would be different angles and targets that would it set out, and in between it would do some sort of regression analysis. But due to environmental perturbations, it cannot gather so much of data. So this relies on platforms like simulation platforms, different apps like sensor array analyzer app, which are part of MATLAB toolsuite itself, to generate this type of synthetically simulated data. So simulated data can also be generated. Bharat Electronics Limited, Ram Pravesh says. And he then used regression learner app to perform regression analysis or to compare various regression models between the 3D radar beam and the target. This is the first vertical of data preparation. The second vertical, Cognition, you may be familiar with this name. It's a big IT company, and it does projects for different type of other clients. So one of the project it did was with various telecom service providers. And what it is trying to do is find out customer churn from one service provider to another service provider. Whether the customers is going to very soon convert their mobile phone service provider from one particular type, maybe from Airtel to Geo or Geo to Airtel or various type of this combinations. So what it does is it captures that data and then does various sort of machine learning application fitting. So this predictive models to identify or to predict customer churn was done using MATLAB and various types of machine learning models. You can see neural networks, decision tree, logistic regression, various types of model. But why did it use MATLAB? Because it provided clear results faster. So the algorithm development time was cut down from weeks to days. So it could complete the project faster in less than half allotted time. In the third stage of simulation and testing, this particular company, Mercedes-Benz, interestingly developed their entire solution on another platform, Python. But then they relied on MATLAB for deploying their solution into a hardware. So without MATLAB and Simulink, they had to go through a manual coding process which was very slow and error prone. And using MATLAB, their development speed increased 6 times. So they converted QKeras deep learning models into a code that can be deployed into automotive ECUs, microcontrollers that go and sit into automotive. And using MATLAB, what essentially they did is using MATLAB's deep learning toolbox, they converted the model that was trained in Python into MATLAB. That was the first step. And the second step, what they did was quantization. So, whatever model they made, every value, if you think of computational terms, it was initially in terms of format like double or floating point of 32 bits. And does it actually require that much of bits to represent a particular number? So instead of doing that, it kind of quantized the bit representation into 8 bit representation or even smaller or whatever is suitable. So this fixed point designer, which has been there in MATLAB for a very long time, so this fixed point designer helped in converting MATLAB's model, or rather the weight and the activation values, into small quantized values. So then the entire model size reduced, and that go and sit on a very memory constrained device. So that was a example of a automotive application which was using multiple platforms for developing their solution. This is TCS using using MATLAB end to end for vehicle predictive maintenance. It is using from exploring data to deployment. The end to end solution was delivered through MATLAB, and you can see things like onboard models, which was computation that needs to be done very close to the system, very close to the vehicle, so that there is less amount of latency in terms of computation. So those onboard models to detect faults, as well as cloud-based model for heavy computations, it covered that entire spectrum of model deployment. And in this particular domain also, you see this term low code approach came in handy. So across different industrial sectors, you have seen, be it in terms of radar surveillance by Bharat Electronics, where it's a government public sector company, and you have seen companies like Cognizant, TCS also using our solutions, so that the entire solution can be developed very fast. And in terms of deployment, it's not just hardware. It's not just microcontroller where you need C++ code, or FPGA board where you need HDL code, or GPUs where you need CUDA code. It can also be in terms of add-ons for Excel. It can be also in terms of exe files. It can be also in terms of libraries that you develop for other platforms. So you develop your solution in MATLAB, but then the final application that you share out with the end users, that can be in any form. It can be a standalone application, it can be another type of library, it can be an exe file, it can be a web app, it can be a containerized application, so on and so forth. The possibilities are endless. But the question becomes here is, be it in terms of developing aeroplanes, automotive, you can see robotics here, or in manufacturing industry, how can we deliver faster solutions? How can we meet the changing dynamically varying requirements while ensuring quality? So we are going to now tone down a little bit and talk about simple example like human activity recognition. On the left hand side, you see the video that is going on. It's from MATLAB Mobile, the handheld device. The benefit of using such a heavy software on a very lightweight version into a platform like mobile phone is because you can capture sensor data. It is capturing the accelerometer data into a MATLAB log, which goes and sits into MATLAB Drive, a cloud based storage platform. You all have access to maybe Google Drive. This is something known as MATLAB Drive, which is a cloud based platform. And here from that cloud based platform, you are again fetching the data into MATLAB's command window. Time xyz 3 axis it is fetching, and then it is plotting the data, time versus x, time versus y, time versus z, and it is going to plot the graph. You can see on the right hand side it is plotting the graph step by step, and here we have the graph. And this accelerometer data essentially can then be used to identify whether you are standing currently, sitting currently, walking currently, running currently, dancing currently. So, what type of activities you are performing. So, even the like I begin with, MathWorks documentation is very rich, right? So, you can see this data being captured, and in MATLAB's documentation, you will find the classification of this human activity using a machine learning approach which relies on feature extraction, using a deep learning approach which relies on something known as long short term memory network, and you also find a Simulink model which kind of develops an Android app, then it becomes a handheld app. So, on one hand, it will capture the accelerometer data from your mobile phone, on the other hand, it will classify the activity and immediately tell you whether you are standing, whether you are sitting. So, it does not have to rely uh, on the desktop MATLAB separately. It will be a standalone app in your handheld device, and you will find all of these examples for your own study. We're going to talk about the machine learning application a little bit in a different context, which is known as low code workflows. So, how does all of this industry that we just saw perform so many tasks so quickly? How does this different applications complete so quickly? All of them praised about reducing their development time. They relies on something known as low code workflows. What are low code tools? So low code tools kind of helps in rapid software development and minimal manual coding. So you can see a video here. So I'm asking it to plot time versus value, and it plots this. But then I can point and click on things like X label, Y label, uh, X grade, and update the code. I did not write this code by hand. I did not do a manual coding. I reduced the amount of manual coding on the right hand side by clicking on some point and click GUI best things. But what are the benefits? You can quickly learn. Maybe you don't know the syntax X level, you don't know the syntax Y level that MATLAB uses or any other platform uses. So it's a shallow learning curve. So it's not a very steep learning curve. On one day you are supposed to use MATLAB for maybe performing multiplication, and the next day you are supposed to build a car out of it. The learning curve is very shallow. The second thing, it kind of teaches you how to code. So while plotting is fine, none of the, in your lab experiments, in your lab manuals, you have seen your educators might emphasize on things like, why haven't you written a legend for this? Why haven't you labeled your accesses? So it teaches you how do you code. So that kind of does gets the job done faster. So your objective was to plot this, so you got that objective accomplished first, you solved that task first, and then you learned about the coding. So you code later. And it's not just for beginners. This low code tools kind of is one of the essential things that helps in getting faster time to market. So let's bring back that example of human activity recognition using signal feature extraction and machine learning. Again, from the MATLAB documentation, let me open that particular MATLAB documentation, copy this link, paste it into MATLAB's command window. So this is the example that has opened up. I'm going to load the data it has already captured. You can see an accelerometer data being captured. I am going to take three types of features here: statistical features, time based features, and frequency domain features. Three types of features, then I concatenate statistical features, time based features, and frequency domain features into a table. Now I have around 22 features here. And this is a code that has been written here to do some sort of partitioning, holdout partitioning, and then it trains an SVM classifier, and then it predicts using something known as confusion chart. So using the confusion chart, it says that the accuracy is 95%, but some of the times it is misclassifying running as walking and standing as sitting. So if you see the confusion chart particularly, on the y-axis I have true classes, on the x-axis I have predicted classes. So the running is being classified as walking, sitting is being classified as standing. So it is confusing between running and walking, sitting and standing. That's why this type of a matrix is known as a confusion matrix or a confusion chart. But what I want to do is now modify this particular example again. So I took again another example and I want to modify. Instead of using SVM, how do I know SVM is the best performing? So this is the documentation example, and in the apps tab of MATLAB, you find immense number of apps, around more than 100 apps are there. So this classification learner app kind of opened up, and I have my predictor in the workspace, in the memory, and in the memory I also have a response variable, which is my categorical variable for all the four classes. I remember I performed holdout cross validation. So I perform holdout cross validation. It's recommended for large data set. I am holding out 25%, and I'm setting aside 10% of data for testing. So what it does is it plots feature two features simultaneously in terms of a scatter plot. And if I, let's say, vary the features, something in the x-axis, something in the y-axis, I am able to see the distribution. So I see orange and blue points observations are very well separable. There are some confusion between blue and purple. On the right hand side, I can see from the label blue and purple are kind of running and working, which is getting overlapped. And I have parallel computing enabled. So I am using parallel and training all the classifiers that are there in MATLAB. So I want to quickly compare, although the documentation has been written with SVM in a code based manner, I am relying on this particular tool, classification learner, to quickly compare what other AI models are there, what other AI models can I check for comparison, which is the best performing model, which is the second best performing model. And I can see a lot of these models are getting trained around 85-86% accuracies it are giving, and around 35 models it is going to train within a matter of few seconds. This is the power of low code approaches. This is the faster turn time to market. This is the faster turnaround time that companies industries rely on. They want students to know this type of simulation platforms, so this type of faster prototyping can be done. And I see ensemble based classifier here is apparently performing the best. Back trees, so it's a tree based classifier. There are so many trees, that's why it's called ensemble. And I can test all the models, all the 35 models. I remember I have set aside 10% of the data for doing the testing. So those 10% of data, none of the classifiers have seen. And it says when testing more than one model with the same data set, it is recommended to use the best model on the validation metrics. And if you use the test metrics to select the best model, the recommended approach is to test the model on the different data set. So what it is telling me, using the same data set, I should actually report the validation metrics because it has done multiple times of validation. But if I am using the test data set, I should actually report out the values that has not been seen during testing. So that is why I have set aside a sample of the uh, values, a 10% sample I have set aside. And with the ensemble model also back trees, the confusion between sitting and standing has been reduced, but the confusion between running and walking is still there. This is the test confusion matrix, and this is the validation confusion matrix. Here also, I'm seeing the confusion between running and walking is still there. That's why it's not a 100% accurate result. But what do I do with this model? I can generate a function or I can import this model into my workspace. And once I have the model into my workspace, I can see it already gives me this instruction in the command window. This trained model has been exported from classification learner, and to make prediction, this is how you predict. It is given me the syntax of how do I test this particular data. So this is a one particular app that you saw in practice, but MATLAB has 100 plus apps. And on the left hand side also you can see a button called as design app. So if as end users you are interested to build your own app, you can also do that. And building your own apps is even simpler nowadays because you rely on things like LLMs, Gen AI. So MATLAB integrates Gen AI, or Gen AI is being integrated into MATLAB through something known as MATLAB Copilot. So this is not Microsoft's Copilot. This is a Copilot that has been retrained on MATLAB's documentation. It's a LLM that has been retrained on MATLAB documentation. So all the toolbox knowledge that is there, all the documentation help is there. It has been retrained on that. And there are three types of Copilot features that you can rely on. There is Copilot chat, that is the pane you see on the right hand side. There is Copilot on the editor itself, and there is Copilot actions. So from the menu bar, you can see there are things like explain code, explain error, generate comments. Remember, this was introduced last year only in 25A. So if you are using a release before this, you might not have access to Copilot, right? So now let's see Copilot in action. I'm going to use a very simple example now. If you're interested, you can disable Copilot also from the left hand side because You are students. If you are giving a test, you should always remember that Copilot is there to help your work, but it does not give you the exact solution. So I'm going to I know there are school students, so I'm going to try out something very simple. So I'm going to ask Copilot, can it explain to me what is edge detection in context of image processing? And it gave me quite a long answer. If I scroll up, there is a definition. What is an edge? How is edge detection working? It is based on derivatives. So how does gradient change and all of those things? The common methods that are there: Sobel, Prewitt, Roberts, Canny. The typical steps that is there in applications, and what exactly it outputs. So it outputs a binary result, logical result 0 and 1. So 1 in cases of edges and 0 everywhere else. And it gives me a nice little MATLAB code which I can execute on the command window. But with GenAI also, you must rely on some deterministic approach of tools. You can see two lines, BW equal to H and IM show BW. It's only showing the edge detected image. How can I see the original image? Cameraman diff. I select I. From the plots tab, I can scroll down and see MATLAB image plot, and I can click on IM show. So it shows me that particular cameraman diff, the original find. But what is the real world application of this edge detection? Where do you find edge detection important in context of image processing applications? So let me ask that now to Copilot. And it is generating a response. It is predicting certain text-based responses and also give another code which is a little bit longer than 4 lines of code. So feature extraction, improving segmentation, higher level of vision, noise, cancellation, reducing complexity if you want to process simpler. If you are trying to measure certain edges, all of those can be done. Now, instead of running this right away, let me bring this code into editor. Remember I said aside from the Copilot chat, there are other things also. So let me select this entire code, and in the editor menu, there is this Copilot option where I ask it to generate comments. So it is going to generate certain comments. If I am happy with this, I can accept, or I can, iterate. So prompt engineering is always an iterative process. So it says it is going to read the image and then from the desk use the last 4 steps and then overlay the detected contour on the evaluated on the image. So this is a circuit, and it is going to detect different edges and mark the boundaries with red colored lines. That is what it is doing essentially, right? So this is the script for that it has given. So now what I want to do here, instead of this, I want to ask Copilot. So I can do something like selecting a block of code, right click and ask Copilot, instead of this red lines or red borders, change or apply green borders. So can it update this particular code? So you see R written as the third argument that has been changed to G. So I am happy with this, but does this work? Let me select this and again evaluate this particular selection. And see, the red borders have now been changed to green borders. So this is using GenAI for a very simple solution building and GenAI features. If you are just interested in trying out this GenAI features on a lightweight version, in our MathWorks website, there is something known as AI Chat Playground also, from where you can try out this Gen AI features if you do not today have access to MATLAB Copilot. So we have covered the industry context, AI based solutions in real world, which industries are using for what type of applications. We also saw why industries are using the low code approaches, the app based work approaches, the AI assisted approaches for problem solving. And now let's talk about certain resources, certain things that academia is focusing on. So, engineered systems that you see are all multidisciplinary. There is electronics, there is semiconductor, there is communication, there is programming, there is knowledge of electrical engineering, mechanical engineering. Everything comes into play. So, curriculum should also be interdisciplinary. And from this interdisciplinary or multi-domain engineering system, the trends that we emerge or trends that we see across platform, be it in terms of different industrial sectors like manufacturing, we see robotics. In terms of different delivery platforms, we see robotics. In terms of healthcare systems, we see robotics. In terms of agriculture today, we see robotics. Same goes for electrification. We see electrified grids, we see electrified tractors, electrified vehicles, and AI kind of sits at the heart of everything. While AI sits at the heart of everything, we are seeing solutions ranging from onboard solutions to cloud based solutions, which means it has to heavily rely on high speed connectivity, low latency, high speed data transfer. Hence, connectivity and communication also becomes important. So these are the four verticals which you would also see different types of electives coming out in your colleges. And MathWorks would need to collaborate on engineering education institutions to address these different technology trends in curriculum. So, with that in mind, digitalization in engineering education today, what industry is asking from students? One is digital skills for students, another is digital tools for teaching and learning. Skills that it is seeking is simulation, AI, robotics, and digital tools that it is seeking today. In for teaching and learning, earlier it was PowerPoint, then it was web based and mobile based apps, then it was LMS, learning management systems. You have seen this immensely during your COVID times, and then you have chat GPT and large language models, which are the future. And you see institutes like NIT Calicut partnering with different industries to have industry ready courses floated. Even various institutes introduce mm, projects at first year levels. So projects like data gathering projects using gravimeter to measure the gravitational force in different floors of the building, using rock samples to take out images of the cross sectional areas of the tree bark, using GPS device to measure readings across a same landmark, and then data processing projects. So does can you see that F is equal to gmm by r square, that r varying across different floors from the gravimeter readings? Can you see that actually as a proof of concept? Can you see that in graph when you plot that data? When you have that thin cross sectional areas of the tree, can you actually do uh, you know mm, edge segmentation, edge detection over here, where has the edge appeared? Can you measure the distance from one peak to another and measure what has been the distance? How much can you correlate that with the weather, whether this weather has been favorable for trees growth or not? These are different things that industries are looking for as transferable skills. And as startups, you see also Altigreen looking at electric vehicles, electrical autos. Ether is a startup that was built out of an engineering institution only. IIT Madras students, they started their journey of ether energy at the institution itself, at the incubation hub of IIT Madras. Range Zero developing pilotless helicopters. So importance of aerial robotics comes into play. And all of this they built on MATLAB so that they could rapidly test, prototype, and deploy. With MathWorks Accelerator program today, across the world, you see across 42 countries, and it has maybe even increased beyond this. You will see hundreds of startup accelerators, incubators today using MATLAB based solutions. And to start off, where do you get started? You can start with the online training suite, which also gives you certificate. You see a MATLAB based platform on your browser itself across different types of courses, be it from MATLAB, be it for simulating, be it for things like image processing, machine learning, so on and so forth. And you can also explore hands-on opportunities. So as an incubation center, you maybe realize the importance of things like hackathon. As students, as school students, as college students, you may be participating, your seniors may be participating in Smart India hackathon. So MathWorks also hosts their problem statements there. We last year floated something known as AI challenge. Every year we tie up with IEEE Signal Processing Society to host a problem statement or a competition there in terms of signal processing cup. And we also have a collection of challenge projects. So I see many students reach out to me in terms of referral for internship, full-time position at MathWorks. So this is your go-to thing. So MATLAB and Simulink challenge projects. And if you see the rewards from their endorsement for position, LinkedIn recommendation, this is a research scholar from IIT Guwahati getting a LinkedIn recommendation from the principal robotics research scientist at MathWorks. And each of these challenge project solutions, if you see on our YouTube platform, they have very well documented YouTube videos as well as GitHub solutions. So this kind of builds your profile also for various professional activities. The student that I was mentioning just now about Bhavik Patel from IIT Guwahati, he developed this snake-like robot modeling using MATLAB. This dashboard, this visualization, mechanics explorer, this everything is on MATLAB. And if you're interested, you can take this particular slide deck today and read about the solution. And not just IIT Guwahati, IIT Gandhinagar, Veltech Institute, VSSUT Bulla. Across India, you see students picking up AI-based projects from our Challenge Projects program and developing solutions for real-world challenges. With that, I'll end the talk here. If you have any particular questions, if you have any particular queries, feel free to put them in the chat, or maybe you can unmute, or I would request you to scan this particular QR code to record your attendance and give us some feedback on how did you like that particular session. If you want to connect with us, our email IDs are also there on the form itself. With that, I'll conclude and hand over to Manoj.
Thank you, Martin, for the engaging session and briefing out the Simulink and MATLAB's offerings. So, a couple of questions from my end actually. Seeing students engaged in Fab Lab or developing multiple projects also, where they perform in groups, and when they're having any kind of idea, they do develop that particular project within a span of 3 to 6 months, and they're coming up with their prototype. We have saw multiple students have been doing now with the Raspberry Pi and other things. Sensors are available, not heavily in this domain, but few of them worked on simulation and UAVs also. Okay, so my major query will be how these student can access these facilities or these kind of softwares. Again, these are purely students, and they do have access to certain systems and limitations are there also, but how they can access, because there is campaign or again startup facilitation program, but these are purely students who are still working on. So yes.
So, MathWorks currently ties up with 300 plus institutions throughout something known as a campus-wide MATLAB, which is a MATLAB subscription where students can, using their institute's email ID, access MATLAB anywhere, anytime. Even they are going for, let's say, a conference outside of India. Using that institute email ID, they can access. But institute then have to subscribe through the campus-wide program. And there is another variant of this where institute can subscribe today about perpetual mode where they sign up for the version that is released today, and then with the version they release today they have unlimited access, but then they do not get the updates. So if they're interested in that updates, then they have to subscribe on the campus wide mode, or if they are interested in the lifelong access, then they have to subscribe in the perpetual mode. But this is what I am aware of. I am not a sales representative from MathWorks, so if you are interested in that particular question, I can connect you with our sales representative and you can get a better response from them.
Okay, okay. I think I believe Kapil ji, I'll have a chat with Mr. Kapil and he might
Sure.
help me out on all this. So it was quite engaging also, and we had previously session here at AIC Nalanda hosted the founder, and Kapil ji was here also back in few years. With this we'll end the session here, and just in case we have any queries, then okay. I got the quick. Yeah, Prasun Banerjee. Okay, Banerjee
Uh,
ji, I will get back to you on the same. Thank you for sharing the contact details. So we'll end the session here with a word of thanks again. Thank you so much, Monalisa, ma'am, for sharing these the insights again, how these are practically getting used, and the drone simulation initially that you have showcased, that was quite interacting and changing the live the color of that from red to green, and interacting with this co-pilot you was mentioning about, that was quite interesting thing, and I hope that is going to help in these students to iterate their ideas and work on their prototype. As well as thank you so much Kapil ji for again partnering with us for this particular program and collaboratively organizing, in thanks to Math Labs also. And I would now like to extend my gratitude to my whole team, as well as Mr. Durga Prasad Kudo, CEO of AIC Nalanda, for his continued guidance and support. Mr. Manas Kumar Samantray, and his Chief Innovation Officer of AIC Nalanda, completely managing the innovation wing. Uh, thank you so much who have joined with us and over the YouTube also. So with this, we'll conclude today's session and looking forward to engage with you for upcoming sessions. Thank you.